Hello, Frank, and welcome to the Star Trek question. Today we're going to be discussing what is going to happen on the Star Trek Starship Enterprise. Sorry, there's a fly on my whiteboard. On the Star Trek Enterprise when an infection outbreak occurs and grows linearly first, and then we'll talk about exponential. Then we'll draw their graphs. So first we're going to start with our linear function, which is always y equals mx plus b. Love it. Learn to love it. It's a great thing. So that's our special base equation. Next, we're going to have our base table, which is x and y always. These represent the two faces, this being a table and that being an equation. The last one would be a graph. Sorry, that's linear. But we'll get to that later on in the questions. So what we can do is start inputting information. So in the first hour, there were 10 people, but for the sake of data, it's going to be 0 and 10. And then in the second hour, there were 22 people infected. So in the first, 22. Because our starting point was 10, and then we grew up to 22. Before that, there were none, so that doesn't really imply into the situation. Let's make that a bit longer. So now that we have this, we can already start finding parts of our equation. Sorry, my dog's barking in the background, if you might be able to hear that. For example, m. We can find that. That's basically just the slope, how much this is growing by. So, if we're to do that, 12, that's our slope already. So, y equals 12x plus b. And our b is going to equal our y-intercept. When x equals 0, y equals 10. Y equals 12x plus 10. Now we can use this to find other things, such as, later on in the question, there's a direct quote, after 3 hours, how many people will be sick? So we don't really care about 2, but 3 we do care about. So, in the third hour, we can input that for x. Y equals 12x plus 10. And if I refer to my cheat sheet, I can tell you that 12... There we go. 12 times 3 plus 10, referring to the cheat sheet, that is going to give us, something or other. 46. This is going to be 46 because 12 times 3, I could have done that in my head, is 36, plus 10 is going to be 46. Y equals 46. So, we can input that right here, 46. Yay! Oh, alien smiley face. Spanish. All in honor of you, Frank. Okay, anyway, moving on, there is what happens in 3 days. Well, 1 day equals 24 hours. And so we want to, since we're working in hours, we're going to have to transform that. That's the word. So we have 3. Nope. The information we know is 1D equals 24 HRS. 1 day equals 24 hours. So if we wanted to find 3 days, we would do 1 over 24 equals 3 over x. 1 times x is x. We're cross-multiplying here. 3 times 24 is 72 equals x. So therefore we can input that for our x, since that's the number of hours, 72 hours in 3 days. 72. And now we'll input that into our equation. Y equals 12 times 72 plus 10. Once again, cheat sheeting it, I can tell you that, cheat sheet. Let's go with that. That's always a good way. Y equals 874. Just for future notice, the cheat sheet is work that I did earlier, just so I can make this video a bit shorter. I'm not just like stealing this off the internet. Here's what it looks like. It's on a plate. Anyway, furthermore, in the question, how long does it take the disease to infect 100 people? We can tell that by inputting 100 for our y. 100 equals, that's a drum set I just knocked into. 100 equals 12x plus 10. We would subtract 10 from both sides. 100 minus 10 is 90 equals 1, 2x. And then divide 90 by 12. Or divide both sides by 12. Let me whip out a calculator really quick. 90 divided by 12. 7.5. Whoa. So 7.5 equals x. Therefore, in the table, it would look like 7.5 and 100. There we go. So, now that we've done that part, let's keep on trucking. We'll leave this in because that's important. Furthermore, we have, if it takes 8 days to discover a vaccine, and that vaccine only yields enough to get 2,000 people cured, will that be enough? Assuming that the Starship Enterprise can hold 2,000 people. Anyway, to do that, we would have to input... So we would do the same thing, the same unit conversion, but 1 over 24 equals 3 over equals 8 over x. Once again, whipping out the calculator to do 8 times 24. 192. Yep. 192 equals x. Now we can input that in right here, 192. So basically, if our y is going to be greater than 2,000, then we're not going to have enough vaccine to get all these people cured. So y equals 12 times 192 plus 10. $192 times 12 is 2,304, plus 10 is going to be even more than that. We're already over 2,000. Y equals 2314. And that's a problem, considering the fact that we only have enough for 2,000 people. We're already 314 over that many. So, the answer is no. Sadly, 200, however many, are going to perish. The others, however, will be able to live. That 2,000 right here, they're going to be alive. But 314 will die. 3.14 equals pi. Next video. Good morning, evening, night, whatever time you're watching this. Frank, right now, I'm going to be doing the exponential part of the Star Trek equation. So, we're going to start with our XY table, which is almost exactly the same, at least for the first two. That's 0, 10, 1, 22. Except now we're working with a different equation, which is y equals a b to the x. B is the multiplier, a is the y-intercept, and y and x, or whatever y and x are. X, once again, is, hours. Y in... Might have forgotten to write those in on the last video. Terribly written, sorry. But anyway, it's seeable. So, now instead of working with a linear equation, we're working with exponential, which means that we have a multiplier that's getting multiplied to an exponent. The exponent is x. So, in this case, if we were to plug in 1 and 22, then b and x would work it out so that it equals out. That's really obvious. Also, that's a y, not an x. So, what we can start to do is find a and b, because those are the main things. Once we have those, we can plug in any y and x and find the other one. So, y equals, a is the y-intercept. When x equals 0, y equals 10. We can plug in 10 times, now it gets a little bit trickier. We have to find the multiplier, what this number is multiplied by to get that one. In this case, it's pretty easy since it's 10 and 22. It's very obviously 2.2, just because when you multiply 2.2 by 10, decimal point moves over and becomes 22. But another way to do that would be just 2.2 divided by 10, or sorry, 22. We haven't gotten to that part yet. And that would come out to 2.2. So our multiplier is going to be 2.2 no matter what. 2.2 to the x. So here is our equation that the entire problem is going to be based around. So now we can start to solve for those other parts of the question. So for example, assume that it spreads exponentially. How many people would be sick after 3 hours? We can do that. Skip 2 once again, but go straight to 3. So in 3 hours, since x represents the hours, y equals 10 times 2.2 to the x. Then when we whip not to the x, it's to the third, because 3 is our hours. 2.2 to the third equals 10.648. 10.64. Yeah, that's it. And then times 10 is going to be 106.48. So y equals 106.48 in that case. That means that 106.5 people are going to be infected. So I know it's not possible, but that's just how data works. I'm sure you know that. Anyway, so the next part asks about 3 days. So we'll do those same unit conversions that we did yesterday. I'm filming these over 2 days. So 1 day equals equals 24 hours. 1 over 24 equals 3 over what? Well, 3 times 4 equals 72, or 3 times 24 is 72. 72 equals, the question mark is an x slash question mark. So 72 is going to equal our x, so we can put in one of these little things, 72, and plug that in. So 22, or 2.2, I'm just doing this in my head, I'll write it out for you. 10 times 2.2 to the 72nd. 2.2 to the 72 equals, oh boy, that's a large number. That's a very large number. I have it written out somewhere, I'm sure. See if I multiply that by 10 if it becomes smaller. No, it's still in scientific notation. So, times 10 to the 25. So that means that the decimal point is way over that way. So that's just a ginormous number. So, I guess we get to write it in scientific notation then. 4.51266. Nope, not 666, 664. 216 times 10 to the 25th. That means that this decimal point is way over there. So this just keeps going and going, and the decimal point keeps going and going till we're at 25, somewhere over there. So there's a decimal point somewhere over here. So that's a giant number, so big that we needed scientific notation to write it in. So what we're going to do is continue on. That's just a giant number. We can live with that for now, though. So, how long would it take for the disease to infect at least 100 people? Okay, 100 people is going to be easy. because, or actually not easy, because we need to use logs. Since 100 people, that's the y, it gives us the y. 100 equals 10 times 2.2 to the third. We can, or to the x. Whoops, trying to find the x this time. So now we're going to divide both sides by 10. So it's going to be 10 equals 2.2 to the x. Now we get to use the logarithms. I had no idea what a logarithm was until this morning when I did some research, and so my explanations might not be great, but I checked it with the original and it plugs in perfectly, almost perfectly. It becomes like 99 point something when we're trying to get these equal out. So what we would do is pretty up that do log times 10 equals log times 2.2, and now there's some property apparently that you can take out that x, and wait, I think that parenthesis might be out here instead. Yeah, so you can take out that x, put it over here as a not exponent anymore, and then if we do log times 10 divided by, we're trying to isolate this, so we divide that by log 2.2. If we do that to both sides, what is this? Error. That can be a g now. 2.2. Then that will give us log 2.2. 2.9203673. So 2.92 equals x. Yay! I don't know why logs work. I guess we'll learn it eventually, but it does for our purposes. We can check this by plugging that into the original equation. So doing 2.2 to the 2.9 equals 9.84 times 10 is going to become 98.4, which is very, very close to 100. So I'm assuming that some decimal place or something gets rounded at some point, like right here. When we round it, that might be where that 2 is going. So 100 is approximately, I guess, 98.4. That probably got messed up when we were estimating. There is one more thing. Let me try that really quick. Times 10 divided by 2.2. Yeah, it comes out the same. So we're close. We come up very close. But basically, what we're finding out is that what are we finding out? When y equals 100, I believe x is going to equal 2.92. So it will take 2.92 hours for x to equal 100, which makes sense, or for y to equal 100. So over here, let's do a little arrow, 2.92, which right before 3, which is 106.48, is going to give us 100. Yay! So now we're almost through this half of the question, this whole exponentially part. Then we get to do the graphs. But there's still one more part, which is how many hours does Dr. McCoy have to discover an antidote if you will only have enough serum for 2,000 people? So, once again, we're going to have to find y for infected. So, I think that means we're going to get to do some more logs. Since this time it's not giving us that 8-hour time period and saying, is that enough time? Will everyone be dead by then? Instead, it's giving us that 2,000 that we need to find an antidote within some amount of time. So it's there's 2,000 people to cure. How much time do we have is what it's asking. So let's erase some of this since we've already got it written in our table. And now we can start. So 2,000, since we're going for y, the amount infected, equals 10 times 2.2 to the x. Once again, we'll divide 2,000 by 10, which is going to give us 200, equals 2.2 to the x. That's either in or outside of the parentheses. And then we'll do log of both of them. So log times 200, yeah, you can still see that, equals log of 2.2 times x. And now we'll solve those. Log 200 divided by log of 2.2. We're just dividing both sides by 2.2 in order to get it. It's going to be 6.71. Let's just round that up to a 2. It's 6.7189 or 98. So 6.72 equals x. So basically, if we have only enough to cure 2,000 people, we're going to need to find that cure within 6.72 hours, because that's what x equals. So what that would look like on the graph is 6.72. Oh, that's more up here. 6.72 and 2,000. And once again, that's going to come more after the 3. This graph, or this table, is not necessarily in order at the moment. But that gives us all that we need to solve for in this case. Unless I find something, I'll go back and do a video on that. So that is my answer. All right, let's get to making a graph. I've got my calculator out. This is the third part of my video, and I just want to conclude with part C. So basically it's asking, if we have the two graphs of our two equations, would either of them have an asymptote? And we can find that by just drawing a quick little graph and showing about what it looks like. The here's 10, that's the y-intercept, or yeah, y-intercept for both of them. This is y, which is going to be the inverted, and this is x, which is the hours. So basically what the graph looks like is around 5-ish over here. This goes up and meets at 10 and keeps going, and that keeps going that way. That's for our y equals, oh no, what is the, here it is, 10 times 2.2 to the x. That's what this one is. And then we have our other equation, which is y equals 12x plus 10. And that's going to look a little bit like around, I think it's 0.25. It crosses here, so it's about 0.25. And then it crosses also here. Let's connect those dots. Great. So this is a little kind of what it looks like. The lines aren't perfectly straight. Not everything is wonderful, but this is a crude graph of what these equations look like. And it's good enough for our issue, which is, do either of them have an asymptote? And my answer, let me get this a little bit more centered, is yes. This one, our exponential, will have an asymptote, and the asymptote is the x-axis. How do I know that? Well, I always like to use the example of a guy and a wall. So, here's our guy, here's our wall. He doesn't have arms. Now he does. Now he's an amputee. So, he wants to go to the wall, but he has a problem, which is that he can only go halfway to the wall every time. So, he goes halfway to the wall, then he goes halfway again, and then he goes a little bit more, and then half and half, but he can never ever touch the wall, because as close as he gets, he's always only a half from what he was before. He's never one entire thing. Even if he goes 99.9% of the way to the wall, and then 99.9 again, 99.9 again, he's always that 0.01 away from that wall from his previous place, so he's never actually touching the wall. That's what's known as an asymptote. This is also an example of exponential decay, by the way. So our little amputee friend has found our asymptote. And in this case, our asymptote is just the x-axis. And that's because if we completely amputate him, if we have our x and y table, this is the hours, this is the infected, and then we go back to that 0 and 10, and 1 and 22, and 3 and whatever that was, or that would be a 2, who cares, but that doesn't matter for this. If we have that again, then we know that we always multiply by 2.2, 2.2, you always multiply by that. But to get from here to here, you could divide by 2.2 to get 10. 22 divided by 2.2 is 10. So, what would you do to get negative 1 in the x? Well, you would divide by 2.2. So, that'd be 10 divided by 2.2, which equals 4.4545. So as soon as we cross backwards, we go directly to 4.45, so like around, I don't know, here-ish. And then we divide that again by 2.2. Whoa, let's delete some of that. 2.2, and that gives us 2.0616 on the y. So it's about like here, let's say. So it just keeps getting smaller and smaller and crunching and crunching and crunching, and it'll get like here and here and here and here and here. It'll make the same thing with our guy with his wall. His flat leg, he's doing the splits. Yay. And then here's our wall. He always gets closer and closer and closer, but can never actually touch it, because as you keep dividing by 2.2 and 2.2 and 2.2, it gets close, but it's never 0, because unless it is 0 that you're dividing by 2.2, 0 divided by 2.2, then it will never be 0. And yeah, that just doesn't work. So, and the previous number is never going to be 0 because you're always dividing by 2.2. So it just makes this infinitesimally small space, increasingly infinitesimal, by the way, of exponential decay downward towards that x-axis, but never actually touches. Whereas our linear equation, our y equals 12x plus 10, in that case, we're starting at 10, and then we're going up 12 and over 1, and up 12 and over 1, and up 12 and over 1, and that just makes a line. So, in that case, there's a direct slope. There's a total slope that's always going to occur, always moving us away from the y or x axis, and always touching both. So, there's no possible way to get an asymptote out of a linear function. Therefore, I have now concluded, I believe, my vlog for Algebra 2 Semester 2, the Star Trek problem. Thank you for your time and watching.